Imagine you have an API that takes almost 1 second to respond. Every time a user opens the app, your backend does the same expensive work again. It receives the request, connects to the database, searches the data, builds a response, and sends it back to the user. Now imagine the same API responding in 50 milliseconds. Same request, same data, same result. The difference is one backend trick: caching. In this video, I will show you how caching actually makes APIs faster, where it fits in a real backend systems, and the biggest mistake beginners make when using it. Let's start with a simple example. Suppose we have an API endpoint like this. For getting products, this endpoint returns a list of products for a mobile app or web app. Without caching, every request goes directly to the database. So if 1,000 users request the same products page, your backend may hit the database thousands times. That is a problem. Most of the requests are asking for the same data, so why should the backend repeat the same expensive work every single time? That's where caching comes in. A normal API request usually looks like this. Client calls the API is communicated with the database, and then it returns a response to the client. The slowest part is often not the Java code itself, it's usually one of those things: database queries, network calls, external APIs, complex calculation, or reading large amount of data. So when people say my API is slow, the real problem is often my API is doing expensive work too often. Caching solves this by storing the result of expensive work temporarily. So instead of asking the database every time, the API can reuse the previous result. What is caching? Caching means storing data in a faster place so you can return it quickly later. The first request is usually slower because the backend still needs to get the data from the database. That's called cache miss. Clients communicate with the API to get the data from the cache. It doesn't find it in the cache, so it goes to the database, and then it returns to the cache to be returned to the user eventually. But the next request can be much faster because the data is already stored in the cache. That is called a cache hit. This means the client calls the API tries to find the data in the cache, and it actually finds it, so it returns it directly to the client without wasting any extra calls such as communicating with the database. So the backend avoids the database completely. That's why caching makes API much faster. Not because the data magically changes, but because the backend stops repeating the same work again and again. Simple real example. Let's say this API returns product categories. Categories do not change every second. Maybe they change once per day, once per week, only admin updates them. So this is a great candidate for caching. Without caching, request 1 calls the database, request 2 calls the database, 3 and 4, and any number calls the database. With caching, for request 1, the data is not stored in the cache yet, so it communicates with the database first. For request 2, the data is now stored in the cache, so it is now retrieved from the cache. Requests 3 and 4 also from the cache. So basically, the first request is the database, the remaining requests are from the cache until you evict the cache. That means the database does less work, the API responds faster, the system can handle more users. In Spring Boot, caching can be very simple. For example, you may have a service method like this. Every time this method runs, it queries the database, which is not optimal. But with caching, you can do something like this. Now, Spring Boot checks the cache first. If the data exists, Spring returns it immediately. If it doesn't exist, Spring runs the method, gets the data from the database, stores the result in the cache, and then returns it. That is the basic idea. One annotation can change the flow of the entire API. Think of the database like a warehouse. Every time someone asks for a product, going to the warehouse takes time, but caching is like keeping the most requested products at the front desk. The first time you still go to the warehouse, but after that you already have the answer nearby. That is why cached responses are faster. The cache is not replacing the database. The cache is protecting the database from unnecessary repeated work. Important warning you need to be aware of. Caching has one dangerous problem: old data. For example, imagine you cache a product price, the old price is $100. That's an old price. And then an admin updates the price to 80, but your cache still has 100. Now your API is fast, but it is returning the wrong data. A fast wrong answer is still a bad answer. So caching is not just about speed. It is about deciding how long should this data stay in the cache. When should we remove it? When should we refresh it? This is called cache invalidation. It is one of the hardest part of caching. When should you use caching? A good rule of thumb is cache data that is read many times but doesn't change very often. Good examples are product categories, user permission, configuration settings, country list, popular articles, homepage data, and expensive report, maybe dashboards that don't change often. Bad examples are bank balances, live order status, private sensitive data, or anything that it changes every few seconds. Caching is powerful, but you shouldn't cache everything. You should cache the expensive things that are safe to reuse. In real production systems, many teams use something like Redis for caching. Redis is fast because it stores data in memory. So instead of every API instance storing cache only inside itself, Redis can be shared across multiple backend servers. The architecture usually looks like this. The API checks Redis first. If the data exists, return it. If not, queries the database, saves the result in Redis, then return it. That simple pattern can reduce database load time dramatically. And by the way, this pattern is called single source of truth. So caching makes APIs faster because it changes this. Every request goes to the database into this. Only the first request goes to the database, repeated requests comes from the cache. That means faster responses, less database pressure, better scalability, but you must be careful with stale data, expiration time, and cache invalidation, of course. So the next time your API feels slow, do not immediately blame Java or Spring Boot. Ask a better backend question. Am I doing the same expensive work again and again? Because sometimes the fastest API is not the one with more code, it is the one that knows when not to work. In the next video, I can show you how to implement this in Spring Boot using Cacheable and Redis step by step. If you want that, subscribe and I will see you in the next one.